back to Math 135. We're on Lesson 13 now, solving radical equations. Yeah, they may not be all that radical, but anyhow, this is going to be our last in a series of solving equation types things. Then we'll go back into some graphing after this. But you need to be able to deal with all kinds of equations. Because you know, as you guys go out into your fields, whatever that field might be, whether it's in the sciences or in construction or in businesses, I have no idea what you might actually run into in your field. And so we try to give you a broad spectrum of things to work with in the hopes that if you need to use it, you can say, I have seen this before. Okay? Now to start out with, we've got this nice little equation, 5 minus the square root of t is equal to 2. Now of course you know it's called a radical equation because right there sets the radical sign. And I think you're probably pretty comfortable with what I would do to solve this. It makes total sense that I'd want to get that square root by itself because there's only one t in the equation, so you know the game is always isolate that guy if you can. Well, since I only have one, let's add that t over and subtract the 2. We know square root of t has to equal 3. There's no doubt about it. Then, in order to undo that square rooting, it makes sense that I'd have to square both sides. So t has to equal 9. Now, one of the things you're going to find is that sometimes we have some rather strange things popping up. So I said, does your solution really work? When you square both sides, you're opening yourself up to some problems. And so let's double check this. If I put the 9 back in and I have 5 minus the square root of 9, will that equal 2? Well, square root of 9 is 3, so 5 minus 3, yeah, that works. Okay, good, I can take that. I have got one solution, that solution is 9. Okay. Well, now I've got another radical equation, but this time it's got an index of 3, so I have a cube root. And as you look through here, you only see the x in one location. So of course this is another isolate that guy. So let's add the 2 over as a first move. So then the cube root of 2x minus 4 will have to equal 2. Now how would we remove a cube root? We would cube both sides. So cubing both sides, on the left I just get the radicand. That's what we call the part underneath the radical sign. And on the right-hand side, I get an 8. So add the 4 over, 2x equals 12, and x is 6. Now, as it turns out, I still ask, does your solution work? We shouldn't have the problem popping up here that we have with the squaring, but until you're comfy with when and where and why that problem pops up, it doesn't hurt for you to say, oh, maybe I better just check this. If we put the 6 back in, we have 12 minus 4 is 8. What's the cube root of 8? 2. 2 minus 2. Yeah, we got a good answer. Okay, now you're going to think this is a trick question, but I'm going somewhere with it. Find the solution of the following. X equals -3. Yeah, I know, you want that on the final exam, right? Yeah, there's one solution. That solution is -3. It's the only thing that will make that true. Okay, stay with me. Now, I want you to square both sides. If I square both sides, I get x squared is equal to 9, right? Squaring the x comes here, squaring that -3 comes here. Yay! Okay, that wasn't bad. And I said, find the solutions of that. Well, hey, x equals plus or minus 3. What happened? extraneous solutions. You might have heard that before in a math class. Extraneous solutions. How did that come about? Well, that came about because when I squared both sides, which is a legal process to do in mathematics. But what it does is it leaves me open for the possibility of some extra solutions. Because I squared that -3, it came out to be a +9. It really wouldn't have mattered if I'd have had the +3 there. I still would have picked up an extraneous solution. Because when I go backwards, there's 2 answers. Okay? And technically, if this was coming straight from here, I only wanted that -3. And so the +3 would be considered an extraneous solution in that case. Now, it has to do with the fact that we're squaring it, and in the process of squaring it, we lose our negative signs. Everything goes to positive. Okay? Now, we're going to use that information as we go through here, and we want to find our solutions. And in this case, I notice I have an x over here. Ooh, I have one there too. Now, the fact that this is not just a square root of x, this is kind of a complicated mess underneath that radical says, man, I've got to get that stuff out of that radical, and to do that, I'm going to have to square it. Now, you don't want to square it the way it sits right now. You want to move this 2 over because you want to isolate a radical before doing any squaring. Okay? Because now, when I square both sides, which is totally legal, but in the back of my mind, I'm saying, ooh, I might be bringing up extraneous solutions. On the left-hand side, I get 2x minus 1 because the square root and the square are inverse operations and they cancel each other out. On the right-hand side, you've got to remember FOIL. X squared minus 4x plus 4. Do you know where I got that minus 4x? If you have x minus 2 squared, that means take it times itself, and you have outers and you have inners. Remember foiling to do that multiplication? Yeah. Okay. Well, now I kind of have to stop and reassess where I am because I dealt with one of the problems. I managed to get rid of the square root. So then I notice, well, I've got lots of x's around here, but I've got a quadratic. So let's move these 2 terms over to the left-hand side. So I would have, now I have a minus 4x, and I'm going to subtract 2x, gives me a minus 6x. I have a plus 4, I'm going to add 1, gives me a plus 5. So I have 0 equals x minus 5, x minus 1, and x is 5 or x is 1. Okay. Now remember, you must check your solutions. When you square both sides of an equation, that's legal, but you're opening yourself up to the possibility of extraneous solutions. So let's check these results back and see what happens. If we put the 5 in here for x, we would have what? 10 minus 1. We'd have the square root of 9 plus 2. Does that equal 5? Yeah. Okay, I'm good with that. There's a good answer. X is 5. Now, let's check out the 1. If we put in a 1, we would have the square root of, what, 2 minus 1? We'd have 1 plus 2. Does that equal 1? Hey, do you realize that if this guy were negative, it would? It's all about squaring that negative away. This guy is an extraneous solution. He does not work back into the original. He popped up because of the squaring process. Okay? So I have one answer. That one answer is 5. I don't know why I have 3 lines down there. I guess one of them just didn't want to pop up the first time I drew it. X is equal to 5. Okay, talking about 5s, look at that 5 sitting in there as an index. How often do you work with fifth roots? I just thought it'd be fun. It looks terrifying, but it really isn't. Because as you look at this, and of course you always want to kind of look and take a deep breath and think about what you're doing before you get started, I see a bunch of garbage underneath that radical, but thankfully that's all I have outside of the radical. So it kind of makes sense that to clear the radical, I am probably going to be raising this to a power. What power do you think is going to undo a fifth root? How about a fifth power? Hey, do you think raising both sides to the fifth power is going to have the same problem pop up as when I square both sides? What do you think? Well, I won't. But if you're not sure, if you have trouble understanding that when I'm raising that to an odd power, I don't run into that problem, just be in the habit when you're raising both sides of your equation to any power, go ahead and check your solutions at the end, okay? Now, those simply undo each other, and I get x squared plus 2x is equal to, and that's kind of convenient if you've got to raise something to a fifth power, -1. Okay? So I went from having a radical equation with a fifth root to coming down to having a quadratic equation. And we've been doing a lot of these. So we know, get the 0. Factor this. Well, in this case, I have a double root. I have 2 answers, but they happen to be the same. I get x is equal to -1. And if you want, take just a second and double check that back. If I put in a -1, I get 1 plus a -2. Yeah, works good. There you go. There's your solution. Okay? X squared minus 16 raised to the 1/2 power. That's not times 1/2. That's raised to the 1/2 power is equal to 3. Now, I've got a warning. Do not distribute that 1/2 through. You can't do that. This is saying we've got all of this raised to the power of 1/2. Now, do you remember what I said about these fractional exponents? You might like working with that 1/2. You might prefer seeing it as the square root of x squared minus 16. That is the same thing. There is a little index here of 2. You never knew that before, maybe. We don't write it. Again, we're so lazy about things. That missing index on a radical sign is always a 2, which is the denominator right there. Okay. To solve this, I square both sides. Now, if I square both sides, remember what I'm doing? I'm opening myself up to a strong possibility of having extraneous solutions. Well, I only have an x squared, so how about if we add the 16 over? X squared is equal to 25. So when I choose to take that square root, I must consider both roots. But I'm a little bit nervous, so let's check them. Okay. Put the positive 5 in. 25 minus 16 is 9. 9 to the 1/2 power. And you know what? If you would like, because sometimes, I don't know, haven't figured this out yet, but sometimes students feel more comfortable when their calculator gives them an answer instead of their teacher. I promise I'm not lying to you, but you might try 9 raised to the 1/2 power on your calculator and see what it tells you. It's not going to tell you 4.5. It's going to tell you 3. Okay? And so if I put in the positive 5, I get the square root of 9. It's 3. Wonderful. If I put in a negative 5 and square it, that took care of the problem, didn't it? I actually get 2 answers on this particular equation. Hey, you might say, well, we should have known in the beginning that there were 2 answers because of this square. You can really only count that for sure when you're working with your polynomials. And this is not going to be a polynomial with having that 1/2 there, because that could kind of change some situations. Okay? Oh, another fractional exponent. I'm trying to get you a little bit used to that. Now again, you can work with it as a fractional exponent, or you can put it into the root notation. You basically just want to choose whichever you're more comfortable with. If you progress on into a calculus class, you find at that level you really want to work with the fractional exponents. But if you're staying at an algebra level, you can kind of use whichever's more comfortable for you. Okay? So, if you want, you could view this as the cube root of 5x plus 2 is equal to 3. In either case, I know that to clear this, I would raise both sides to the 3rd power. Hey, if I go back up to the very beginning, just for a moment, and say, okay, how about if I raise this to the 3rd power? And of course, I've got to raise both sides to the same amount. And what I'm doing there is I'm taking 2 quantities that are determined to be equal to each other. And if I raise this to the 3rd power and I raise this to the 3rd power, they should remain as equal quantities. Okay? Notice that when you raise a power to a power, you're supposed to multiply the exponents. And what happens when you take 1/3 times 3? You get 1. And if we have an exponent of 1, we just don't write it. So we get 5x plus 2. You can either think of it with the fractional exponent or with the radical notation. And it has to equal 27, the 3 cubed. Okay? Well, now you take a deep breath and you reassess where you are, and you like where you are because that's just a little linear equation. Subtract the 2. 5x is 25. X is 5. Now, was it dangerous for me to cube both sides of the equation? Does that bring out extraneous solutions? No. But if you want, go ahead and check the solution back, just to make sure. Okay. Well, this guy is a little bit of a problem because I see a square root of x and I see an x. Now, by the way, you might say, oh, quadratic form. We did these in the last lesson. Yay, thank you, if you saw that. But I want to show you that here's another option for how to do that. You are right if you recognize that this could be solved as a quadratic form of an equation. And you know, that's one of the things that I think is important in math, that you realize at times there's more than one avenue to get to the right answer. Take what is legitimate mathematics, but whatever you're more comfortable doing. Okay? Well, for this time, we're going to go ahead and add the 3 over. Now, the reason I'm doing that is, first off, it makes sense to condense in any way you can, and I can put my number values together. So adding the 3, I get a minus 6. The other reason that I would add that 3 over is to isolate my radical, because in order to get that x out of the radical, which I really kind of need to do, I'm going to have to square him, and I want him by himself. Okay, so now I'm going to square both sides. On the left-hand side, I get the x. Now on the right-hand side, what must you use? Don't forget the O and the I. You get x squared minus 12x plus 36. Okay? And you kind of take a breath and you reassess where you are and you say, oh, I got a quadratic equation here. All right? Well, let's subtract that x over. So 0 is equal to x squared minus 13x plus 36. Oh, we've actually seen this guy. That's going to be an x minus 4, x minus 9, and we get two answers. X equals 4 or x equals 9. Should I check them? Well, if you're not sure, yeah. You don't want to give your employer a really bad answer, okay? I squared right here. That put me into dangerous territory, so you really have to check it. Okay, let's check back with a 4. What's the square root of 4? 2. So we'd have 2 minus 3. Does that equal x is 4 minus 9? No. However, interestingly, if this sign were different, okay, now that means that this guy is not acceptable. He was an extraneous solution that popped up because of the squaring process. So let's try the 9 in. Let's see here. Square root of 9 would be 3 minus 3. Well, we know that's a 0. Oh, looky there, 9 minus 9. This is a good solution. Okay? So once again, we did have an extraneous solution pop up when we square. It doesn't happen all the time, but it is a strong possibility. Okay? Okay, now we're really going to have fun. Because you look at that and you say, I've got 2 square roots. Okay, so you say, I want to square it. Well, now, if you square it the way it sits right now, ponder for a second the monstrosity you get. Because remember, if I'm going to square that, I must use FOIL. And so what would happen is, squaring that guy is good, squaring that guy is good, but those outers and inners become a big nightmare. Okay. So you say, well, what should I do? What you want to do is you want to isolate these guys. Get them away from each other, okay? So the left, we're going to leave this square root of x plus 5. And we're going to take this radical and add him over. Okay? Now we're going to square both sides. It's still not going to be fun, but it is better. It's less ugly. So when I square on the left, I get just the radicand out. Now on the right, when I square that, remember, squaring means you take it times itself. So I have 2 plus the square root times 2 plus the square root. Okay, I wanted to write that out because I'm going to carefully do this. First times first is 4. Outers is 2 square root of x minus 3. Inners is 2 times the square root of x minus 3. Last times last, a square root times itself, you get the radicand. Okay? Wow, that's ugly. However, as I said, that is less ugly than what I would have had. okay, if we hadn't moved that term over first. Well, let's clean this up, especially on the right-hand side. So I have x plus 5 is equal to, do you realize that those guys are like terms? It's 2 ugly radical plus 2, same ugly radical. That would be 4 of those ugly radicals. And then plus x and a plus 1. Okay? Let's look at a little bit better. But you notice that you have this square root, and so I'm going to have to square again. Now, before you do that, you want to get this guy by himself. So how about if we subtract the x over? Well, that's kind of convenient, because if I subtract that x over, whew, he's gone. That's at least nice. Let's subtract the 1 over, and I get 4 is equal to 4. Oh, this is definitely looking better. Divide the 4 off, and I'm switching the sides. I don't know why we like to have our x on the left, but we seem to like to. And now it's nice to square both sides. So we get x minus 3 is equal to 1. So x is 4. Hey, is there any chance that that could be an unacceptable answer? Well, heaven forbid I squared twice. Yes, it could be. And you might say, but you only got 1. Well, maybe this problem has no solution. So don't assume that just because you got 1, you don't have to check it. So let's check it back. If we put in the 4, we get square root of 9 minus square root of 1. Does that equal 2? Yeah. Okay, good. We will take that answer. But you made that dangerous move twice, so you really needed to check that answer. Yeah? The radicals aren't so terrible, really, and this is the worst that you can get. When you have 2 separate radicals, they can't be combined in the beginning. You need to separate it. Unfortunately, it means you're stuck squaring twice, but you can handle it. Okay, so kind of recap here our work with the radical equations. If you've got a radical in there, and you've decided that that's the way you want to go about solving this, you really need to isolate that radical first. And then raise the equation, both sides of the equation, to whatever power you need in order to clear that radical. If it's a cube root, you need to cube it. If it's a 4th root, you need to raise it to the 4th power. Be sure to check your solutions back into the original, and especially if you're going to raise it to any even power. Okay? Technically, you don't have to check those odds, but if you're not sure, just check them. And if you do get stuck having 2 radicals, get them separated, 1 on each side. And please remember, and you even need to remember this FOIL on some of the earlier problems as well. Make sure that any time you're going to square and you have 2 terms, like the x minus 2 squared, you're going to write out 2 of them. You're going to use FOIL multiplication, okay? And then, unfortunately, you have to isolate the remaining radical when you have 2 of these guys and repeat the process. Okay? Well, hey, we're kind of done with our solving various equations. And in the introductory information, I gave you some suggestions for success in algebra, and one of those suggestions is to make yourself some index cards and put some of these problems on index cards. And after finishing all of these solving, where we solve with fractions, our rationals, where we solve quadratics, where we solve those polynomials, where we solve the quadratic forms, where we solve these radicals, there's so many kinds of problems. And many times students say, well, I can do them on homework, but I get all mixed up on the test. Put some of these on individual index cards and put the answers on the back and maybe where you can get a solution. You know, maybe it's something we've done here together or it's something that you found in your textbook. And then shuffle those cards up so that you just pull one out and look at that equation and say, how would I solve that? That would be a really good way to kind of tie together the ends here as we close this section of solving equations. And when we get back together again, we're going to go back and look at some graphing. Okay? Thanks for joining me today.